All right, today we're going to go over the math method for determining your firing data based off of the observed firing charts, both pivot point method and below pivot point method. So getting into it, just an example from Team Drill 1, they give us an MFP of 118893. The following situation of Bravo Bravo 1001 gives us a grid of 144887. All right, so the first step in this process is to go ahead and convert these into 10-digit grids. So I'll go ahead and throw 2 zeros on the end of both. The eastings and the northings for the MFP and the target. From there, we have to figure out our differences. So we'll just take the larger one versus the smaller one. In this case, 14400 minus 11800. Plug that into our little calculator. And that's going to give us 2600. From there, we can look at our MFP and our targets northings. 89300, 88700, so we'll just subtract those out as is. And that's going to give us a difference of 600. All right, so I have the difference between my targets and my MFP's eastings and my target and my MFP's northings, right? As you see here. Now I have to figure out, is it left or right of me, or is that target north or south of me? Both of those come into play here. So for our eastings, our target is greater on the easting than our MFP. So on a map, if I'm here, my target is going to be to the right. So I look at that. Key thing here, less is west, right? So if that target easting was less, then we'd be left. But in this case, it's more, so we're right. Now we look at our northings. All right, we're at 8.9. The target's at 8.8. That target is less than us, so they're south or down, right? The thing to remember here, more is north. Less is west, more is north. All right, so we got our shift here. We got our right 2600, and we've got a down 600. Well, what do I do with that? In the pivot point method, what I'll do is I'll go ahead and make sure that zeros are indexed, right? We want to look at this as a map. The first thing you do with the map is you orientate north to north. So that's what we're doing here. All right, the zeros are indexed. I'm going to go from my pivot point, right 2600. So 5,000, 1,500, 2,000, 2,500. And then 2 green boxes. I like to make a little index line. That's 2,600. All right, now I'm going to go down 600 from there. 1 big black box is 500. Go another 2 green boxes. And that is where I will place my plot. Go ahead and give it a circle to denote it as the first shot of this target. And since we're using our pivot point method, all I have to do is bring it over the vertical center line. So I'll take that plot. I will place it over the vertical center line. And there we go. My target is plotted. From here, I can pull my azimuth as well as my range. In this case, the range I see is going to be 2675 meters. For our azimuth, what I'm seeing is 18300. Correction, 1830. Let's look at the answer key to see how close I was. They have the azimuth as 1830 and the range is 2675. So that's perfect. Now, once again, you have a tolerance of 10 mils to left or right, as well as with range, you have a 25 meter tolerance. This is a way to do it without doing anything with the map. There's no guesswork, no protractor errors, no plotting errors. As long as you do this all right, you will get a very close, if not the exact answer. Now we're going to go ahead and go into how you apply this to the below pivot point method. All right, now I'm gonna go ahead and show you guys how to apply this to a below pivot point method on an observed firing chart. So this is an example from Team Drill 1. We have target Bravo Bravo 1004 and our MFP grids listed right here. First step, make sure everything's listed in a 10-digit grid format, right? We have a grid given to us as 150914 for Bravo Bravo 1004 and our MFP 108902. Just tack on 2 zeros at the end, make them into 10-digit grids. Now I gotta find the difference. Our target grid is greater than our MFP, so just subtract those two. Plug that into the calculator, 15000 minus 10800. It's gonna give us 4200 meters of a difference in our eastings. We'll do the same for our northings. 91400 because it's greater than our MFP, 90200. Find the difference. And that's going to give us 1200 meters. All right, we have our differences. What do we do with that information? We got to determine, is it right or left? Is it up or down? Looking at our eastings, our target is greater than our MFP on the easting. We know less is west, so if it's more, it's east, aka it goes right on the map. So we have a shift of right 4200. Now let's look at our northing. The target's northing is 914, ours is 902. They're more than us, so they're north of us, or rather up. So we go right 4,200 meters and we go up 1,200 meters. So let's go ahead and transition into our plotting board. You'll see here, I already have set up my MFP and my mark center sector with the reefer deflection scale over the top. If I'm going to apply this math method here, I need to ensure that I'm indexed at 0. So I'll go ahead and move to my 0 line, orienting north on our plotting board. From here, I can take my range arm. I can measure right 4,200 because that was the shift that we had determined prior as what we need to do to plot this target. So line that up nice and pretty like, go to the 42, and we'll just place a dot. That becomes our reference line. We'll go ahead now, line up the 0 with that dot. Once again, ensuring that our range arm is nice and straight. Our up 1,200 was the measurement that we got. So we'll just go up to the 12, place a dot, and that becomes our target plot. From here, we parallel plot the 2, getting as close as we can to perfectly parallel to each other. And we can read our deflection, azimuth, and range. So our deflection that we're pulling here, 0.7, 1, 2, 3, and it aligns pretty good with the 3. So 0.733 is what I'm going to go with for deflection. For azimuth, I'm going to say 1317. And for our range, go ahead and line these two up with the range arm. I'm getting 4375. So now if we go ahead and compare that with the answers given to us by the team drills as a safety check. They have a deflection of 0.730. We're checking. Their azimuth is 1320. We're checking. Their range was 4375, and we're right on the money. We are checking. So this just goes to show we have that 10 mil tolerance. It's going to be different every time you do it. That's okay. As long as you're within 10 on deflection and azimuth and then 25 on range, you're good to go. So that's how you apply the math method to both of the observed firing chart types, pivot point and below pivot point. Hope this is helpful for you guys, and let me know what you think. Obviously, this is something that you should apply in moderation. There's always the guaranteed reliable map method, where you actually lay out the map, you plot the 2 points, draw your straight line, measure your distance and direction from that, and then apply that to your plotting board. Those methods still apply. This is merely an alternative method that might be able to help you. Maybe you're great at math, and that makes you faster, right? This is all about being more lethal. So whatever it is that helps you guys be better at this,